Hello, friends. Uh, Welcome to Eastern Academy. We are discussing about embedded system as a part of embedded system programming. This is session 11. We are discussing about DC motors. Okay, actually motors. And today we will discuss about DC motors. And before we get into the DC motors, I would like to discuss with you some important points, which I was thinking for some time. I'll just get back to the board and I'll ask you something. There were certain things are very important. Okay, you are into the embedded system industry. Now you know that things are possible. Okay, so what are the things? First, they understand there are three things followed by the industry. There are few things. Okay, what is that? The first one is called GPIO control. That is what we are discussing. What we are discussing is on a chip, how to control a pin. That's it. We don't do anything. We just don't do anything. The pin, by controlling 0 volt or 5 volt, you are controlling the devices. You are controlling devices. We first initially tested LED, then 7 segment, then motor. Then we will go back to the inputs. Okay, the same thing. Once you have done the GPIO perfectly, you say that I'm perfectly all right with GPIO. Then you move on to controller. This is slightly easier than GPIO. Understand? This is easier than GPIO because the controller, you will give a task and he will complete it for you. So the software, what you have written for GPIO is already written inside the controllers. So you do not have to write the software, you have to give only a command. See, for example, let me give you a thing. In GPIO, example is you should cook. You should know how to cook a food. But here, you order to the chef to cook a food. You need not have to know about cooking. The big difference between the controller and the GPIO is, in GPIO, you should know everything. In controller, you need not have to know anything. The controller is easier than GPIO, please. But the problem is, there are controllers inside the microcontroller or outside the microcontroller. So inside the controller, if it is a microcontroller, your microprocessor can directly access. There will be address. Like you will say that star X is equal to the address. So there are two type of controllers inside the microcontroller, outside the microcontroller. The outside the microcontroller, you will talk through I2C, SPI, UART, CAN buses. Both are same. So this is called interfaces. Now people make the life much easier. The fourth one, that is called functions. So I'm telling you that what I'm trying to convey you is that this is the one which you are doing right now is the toughest. Don't ever think that what is coming later or toughest. No, this is the easiest. Understand? Do you agree this? Right now, what you are doing, the GPIO, controlling the LED or 7 segment motor, these are all the toughest programming. But using these functions are the typically easiest way. You need not have to know anything. You just call it, let's say you wanted to rotate a motor at 100 RPM. You say that and clockwise direction. And a clockwise direction. You say that motor 1. So you say motor 1, comma, clockwise, comma, 100. That's all. You do not have to know anything. To do this, anybody can do that. In this case, the motor will rotate in the clockwise direction, 100 RPM and motor 1. You may be having multiple motors in the robot. How do you control that? So please understand what I'm trying to convey you is this. No, because you are in the mode of listening. I wanted to get out of you the mode of listening. Because I don't see the programs. Let's say either C programming or embedded system programming. Okay, I need to get the exercises from you. Done the exercises. From that, I know that where you stand. Okay. Without that, if I start explaining the whole thing, they are very nice, but all are waste. Even for example, I taken a session on motors yesterday, and you would have forgotten everything. This is the what typically we do it in the college. What we do in the college is you listen a lot. Now the only thing is you listen from the instead of professor, from the industry person. That's the only thing. But your listening is same. So there will not be a big change on this. What the Eastern Academy is advantage over the college is building a skill. Am I right? That's why you have joined here. You have joined with me, and I also promised you that I will give you a skill. Okay, not the knowledge. Knowledge is sufficient. That's why I'm repeatedly telling you that don't try to listen too much. This is what the habit you are built. You are built over the time. You are ready to watch YouTube. You are ready to listen lectures. These are all no use, please. I'm telling you that these are all no. That's why I created the program. You can attend anytime my program. That's why I'm telling you that. We have discussed outputs. But the moment you say output, if I ask you one question, see here, I have a circuit. I have a microcontroller. And I have a resistor. I have a LED. These are all fixed. This is fixed 330 ohm, as we discussed, because 3 volts will get dropped here. And this will be 2 volts. And I make the pin as a 5 volt. The LED will glow. You know that because it's a 5 volt, this is a ground. So you get the LED to glow. This we have seen a wiring. We have also simulated. Both are same. Now, if you make this is 0 volt, if you make it this is a 0 volt, then this is going to be off. Am I right? This is 0 volt means off. 5 volt means on. Am I right? Please understand one important thing. Please understand one important thing. By writing a program, char star out, that's a port address, out equal to 0x31. That's given by the microcontroller manufacturer. This can change from, if you go to ARM, this will change. If you go to 8050, this will change. Now you say star out equal to 1. It's a bit 0. By making it 1, you will give 5 volt. By making it 0, you will give 0 volt. Now I ask you a question. I want to make the LED to glow off bright. Off bright. But you are not supposed to touch anything. You are not supposed to touch anything. You use only the hardware. In this hardware, how do you make the LED off bright? Can you do that? How many of you can do that? Please. I don't know how many of you actually did the experiment of blinking the LED. This takes only half an hour. I don't know. You don't tell me that you didn't get the half an hour. When I taught in the class, okay, when I taught in the class, I'll go to the board thing. I'll go to the board. Okay, we have a thing. Am I right? We have a board. We connect a small LED now. Let us connect a small LED. And we connect the resistor. I don't know how many of you have done this exercise. That's why I'm showing it to you once again. Please, if you have not done this, do it. That's a very important. Now,
Sir, screen is not visible.
oh, I'll show you. I'll share it with you right now. Thanks. This is a mistake I do always. Thank you. Let me share it. Okay, it shows the video. Fine. Now this is the connection we made it. I'll remove the connection because you can able to. I want you to do. I wanted you to see it so many times, so at least you will do that. See, you allocate some time every day. At least spend about half an hour, 1 hour here. Play with this. Take the LED. They connected here, and take a resistor. Connect it here. I do once again. I could have saved the time by drawing already. I'm not doing that because I want you to see every time. That's why I'm doing it. Now I connect 0. Same way I take the ground. Okay, LED is done. I make it big so you'll be able to do that. Okay, it's visible to you, big LED. Now I write a program. Volatile. You should never forget this. Volatile. Char star this. Volatile. Char star out. That's all we know that. One is for direction, one is for thing. And we give direction as a 0x30 and out as 0x31. Now I make here star out equal to, sorry, start there. Or 0b. Let's assume 0b, 0000001. I use only one bit. I make that bit as a output. You can put either anything. You can use either this, or you can write 1, or you can write 0x01. You can write anyway. I've all are same. This are same. I use only one bit. That's why I made 1. See here. Let us remove the zoom. Now I use only the bit A0. That's why I made that bit as an output bit. All the other bits, I made the 0. I'm not bothered. So you can write anyway, 1 or 0x01 or this. But generally, industry uses this. Understand that. But somebody uses this also to make you to understand. Now, I'm going to make star out is equal to 1, 0x, 0b. I make 1. So, okay, now let us see here. The LED should glow. This we have seen. But today I'm going to ask you something else. Now the LED is glowing. Okay, so quite simple. Now I make this as a 0. I make the 0, then I run the code, the LED will become off. Am I right? So understand the thing what I'm asking. If you make it 1, the LED is going to glow. If you make it 0, then the LED is going to be off. But I want to make the LED to off bright. Now let us see that. I'll do one thing now. I write while 1 out. I on the LED. This is on LED. You may ask that why I'm giving this once again now. There's a reason for that. I'll tell you the reason. I say for now I'm making everything 0. I'm going to off LED. Am I right? This is a small code which we already seen. I'm once again writing this. I make this as a 5 rack. Now I say I declare I. Now let us make the thing. Now you see that LED is blinking. Am I right? Why it is not blinking? Oh, sorry, it's a big time. I did a mixed time. Sorry. I've given a wrong time. Now the LED is blinking. Am I right? Now I reduce the time. See that? Now I reduce the time. Now what do you see? Please notice that. Please notice what I am doing. I am making the time less. So LED is blinking less. I'm making the time still less. Now you see it's still blinking. I make it to 500. Now you see the LED. Am I right? Now I'm going to do a small change here. See, now you don't see the blink at all. I'm going to do a small change here. I make this guy 2000 off. After off, I make it 2000. See that what is happening. Do you see what is happening? If you still notice, I will make it to this guy from 5,000. I make it to 400, 200. Now you see the LED. Now I make it 200 to 100. If you notice something, let me know. If you notice something, let me know. Now I make it to 50. I reduce this time to 50. Now I make it to still less, 10. Then I make it to still less, 5. What you start? Now I increase it this to 2,000. I keep that 5. I keep this one increasing. 2,000. Sorry. What do you see now? I increase it to 4,000. Then what you see the LED? I'm just showing you the. Now I increase it to 10,000. Am I right? You start noticing something. If you make it to still more, but you start seeing the blinking because its case 50 is a big time. Okay. Now I make this as 1,000 and this to 2,000, 5,000. See that now. You see the blink because of 5,000. I make it to 2,000 and this to 200. You will be noticing something now. What you notice? I'm controlling everything in the software. Am I right? I don't touch the hardware. I don't change the resistor. I will tell you now what is happening. I'll tell you the principle here on the board. Then you will know what is that. That is the trick here. That is what I want to discuss with you now. I have shown you with the small LED what is happening. Where if I start changing, see that when I make this, I have on. After on, I make a small delay. Then I make it off. Then I make it delay. That is what you understand. This is on delay. This you call on delay. This is called off delay. Please understand, this is a very important. Okay, on delay and off delay. Okay, is it clear? By changing this, what is happening? Let us see that. Okay. Let's go to the board. So, effectively what we have done now is, on the LED, we just connect the, see, let us assume now, we have a bulb. We have a resistor in your house. Let's take a fan. Both all are same, any device, fan. You supply 230 volts. The fan is going to give you the power. The fan is going to give you the power based on the current you are flowing, I. So the fan is going to have a resistor. So power is equal to I square R, which we'll discuss later in electrical session, more depth. More depth we will discuss on electrical session. Now, is it clear now? So what we are doing here is, we are making the power. How do you change the current? This is having a resistor, R. This is also a resistor. This is called R1. This is called R2. So You know the thing, R is equal to R1 plus R2 if you connect two resistors in series. Now what happened? You apply the same voltage V. V is 230 volts divided by R1 plus R2. The I is fixed. Now R1 is fixed, R2 is fixed. So the current is fixed. So the fan will be rotating at the speed, a determined speed. Now I change the resistor R1. If we change the resistor R1, this will change. Am I right? The total resistor will change. So I will change. Since I is changing, P is equal to I square R. Okay, R2, sorry. So P will change. So the fan speed will change. This is what you call it as a regulator at your house. You call it as a regulator. So it is very clear for us normally. If I have a resistor, if I have a device, the bulb, let us assume. This is resistor. But please understand, all the devices, the resistor is fixed, R is fixed. When you buy a heater or a bulb or fan, any electrical devices, the resistor is fixed. It does not vary. Now, the problem is, if you fix the R also, then I is fixed. Since I is fixed, that bulb is going to give you the same power, P, I square R. That is fixed. Now, my question is, how do I change the power? I have to change the voltage then. How do I change the voltage? Because I give 5 volt only. So what we are doing here is, we do a simple technique. We do a simple technique. By on and off. Please set. I make it on and off at a fast rate. That time what happened? I do on, I do off. When there is on, the current is going to flow. When there is off, no current. No current, zero current. This is I. So what we do here is, we will take the average. We will take the average current. So here is zero current, no current, because it's zero. Let us assume that I have a switch here. That is what you're doing. By writing a program, start while one. By doing this program while one, star out equal to 1, delay. Star out equal to 0, delay. Am I right? I don't know how many of you have tried this at your home on Wiki WalkV simulator or the actual board. How many of you have done this exercise? It's a very small. You should learn how to blink the LED. If you have not done the exercise, you may not understand today's class. That is what I'm repeatedly telling you, that please make use of the class by doing. You need to do the practice. Just watching this class is going to be useless. I will bet. If you watch this class for next 1 month, 1 year also, no output, it's all waste. Please understand. That's why I'm repeatedly telling you that stop watching the class, start doing. But I have to see a substantial thing of how you are doing. Am I right? I don't see that. I want to see that you are doing that practice. Either share the link or ask the doubt or ask the next set of questions. One of them you should do. Either I'm watching everybody. First thing is you should do that. Start doing. You send me the link. I have done. Am I right? See, for example, I'll show you a small thing here. Today, I've asked one of your student, one of your same, our group student. I've asked him to yesterday told him that a documenting. Now you have finished the normal exercise, move on to arm. When he move on to arm, okay, I told him to do the this one documentation. Okay, I told him to write the document. Now I'll share it. I have not shared it. Please, I'll share that. I'll just show you that. I'll show you that what they do actually. Now you see here, I asked him to document it. Okay. Next minute, he has documented it, how he has done the whole work, and share the link. The same thing, same one, same student, same way. What I want you is you have to do that. So please follow. You don't think when I told him, this is what the trick. This is what the trick. I told him, you see here, see the time. When I told him, now you need to document each project that you have done. Upload the code. When I have done today, what time? 10:54 a.m. Today morning, 10:54, I told him to document. I got the result by about 5:42. You understand? Better do the same thing. Whenever you have a doubt, if I ask you to send you the question, when I ask you anything, I'm not comparing. Please understand. I'm giving you only I never like compare. I don't like the comparison. What I want to say to you is, please, more response. You give a more response to me. When I tell you these things, you should know that what is the meaning of this. Why you don't think why I am telling this. You'll be very surprised. Now you think here, without touching the LED resistance, without touching the resistor, same voltage. We are giving only same 5 volt, but I'm going to change the current. How? If you tell anybody, see, we know that very clear. We know that very clear. V is equal to IR. If you don't, I is equal to V by R. We know that. We know very clearly. And P is equal to I square R. But I am telling you that don't change the resistance, fix it. And V is 5 volt. We supply only 5 volt DC. I'm supplying only 5 volt DC. But I want to change the power P. I want to change the power P. How could it possible? That is what I've shown you so far. That is what I've shown you so far. How do you, sorry. How do you sorry, I'll come back to the board. Something wrong has happened. So please understand what I'm trying to say. Otherwise, this course, you will not get the best out of it. If you want to take the course best out of it, take me as a mentor. Okay. Just do small steps. Get out of your college mindset. Assuming you are into the industry. You are getting out of the college, you are in the industry. I don't know what year you are doing. I don't know which year you are working in the college. But still, when you come to me, you treat me as an industry person and you be the industry. In industry, if my junior comes and asks me, if an employee, let's say I'm a manager. If my colleague come and ask me, subordinate, sir, can you teach me this? No, what I will ask immediately, go back. Whatever I given you yesterday, finish it and come give me the result. Am I right? We don't give you the next exercise or next problem unless I wish to finish this one. Okay. Here, I don't wanted to demotivate you. That's why I'm taking the classes. But I'm telling you, this is not the right methodology. This is not the right methodology. But still, why I'm giving? Because I want you to get motivated and get into the practicing. That's why I am trying to tell you that everything is possible by writing a program. Please understand, everything is possible by writing a program. In this case, I am changing the voltage. Think of it. Somebody thought it so nicely and we are doing it. How they do that? It's a very clear. It's a very clear. They do the thing. It's a very clear, very simple way. You see here, I make it on and off. On and off. When I make on and off, for you, the light, the LED, when this is on, LED will become on. When 0 volt, this is V. This is given by your microcontroller. That is your software. Bit 0. You make it here 0 volt and 5 volt by making the while loop. The trick here is, for everybody, for others, if it is on means the LED will glow. For this one, LED will become off. But when you reduce the time of this, then what happens? You don't see the blink. This is actually called, you get the average voltage. We are using the ICE. In the case of LED, use the ICE retentivity power. In the case of motor, the torque. If you make the voltage very fast, then the motor cannot reverse and stop. So it will slow down. See, when I give this voltage, the motor will rotate. When I give it 0, it will slow down. Then, but before that I give it. That's the reason it will slightly slow down. Though it become an average. So this is called on time. This is called off time. This is called period. You know what is this called? Do you know about what is the name people are given for on time? That is called duty cycle. See that? Duty cycle. Why they call duty cycle? Because only during the time motor takes the power, it rotates. That's why it's called duty cycle. When it is 0, you don't do any duty. So the average voltage is percentage. If I say duty cycle is 100%, that means that the power is always on. I make this bit as on always. I make it always on. It's a 5 volt. That means 100%. If it is 50%, that means that I make on off of a time, I make off of a time. You should know what is the frequency. Let us assume that my frequency is 100 hertz, 100 megahertz, or 100 kilohertz. That means that the period is 10 microsecond. Can you tell me how I written 10 microsecond? That you have to be very fast. When I say here 100 kilohertz, if I ask you what is the period, you should come out with the answer. Oh, the period is 10 microsecond. How? It's quite simple. Now, if it's a 1 by 100 kilohertz. This is 10 power 3 kilo. So 10 power 5. So 1 by 10 power 5. So you made 10 top 10 power 6. 10 power 6 means it go to 10 into 10 power minus 6. 10 power minus 6 is micro. That's why I've written microsecond. But you should do all the calculation within about fraction of a second. If I ask you that 25 kilohertz is equal to how much time? How fast? Let us see that. How fast you are giving answer. This, I told you, simple mathematics, addition, subtraction, multiplication, division, not more than that. If you say that I'm not good at even this 4, then it's very tough for you to get into embedded. This one you should give it answer in exactly 1 second. Can anybody give an answer now? I want 25 kilohertz. What is the time? 25 kilohertz. Quick. You can give a private answer, not as a public answer. Anybody? I have not got the answer yet. I have not even got one answer. Answer quick. 25 kilohertz. Please. Anybody? $25 kilohertz is what is a period? Am I audible? Am I audible? Please. I want an answer for 25 kilohertz is what is the period? I have not got single answer yet. I'll wait. I'll wait till you get an answer. This here, this is very important. If you don't know this, this whole topic is not very interesting. This you should do it very fast. Anybody? Quick.
Sir, 5 microsecond.
Oh, type the answer. Chat. On the chat, type the answer. I want the answer in the chat. This is a problem. I'm telling you now, your problem is not with this one. No, it's the wrong answer. It's the wrong answer. I want an answer. 25 kilohertz means what is the period? What is the T? You know, your problem is this. Your problem is we are not, I told you beginning of the class, we have to be very good at addition, subtraction, multiplication, division. We are not strong in that. We should know how to use them. It's not only that addition, subtraction. We should know how to use them. That's why I'm showing you that. No, I'm not going to give it. I'm not going to proceed further. I will ask so many questions. I want the answer for this. Because this is what the critical here. If you don't understand that, my whole entire next class is not going to be very useful to you. Anybody else? Others? At least somebody has tried. I'm really happy that you have tried to give an answer. Others have not yet tried. So there's a problem. So we have a problem now. This is what I'm telling. Where let me stop here. Let me explain this very clearly. Let me explain very clearly. If somebody gives you the frequency, if somebody gives you f is equal to how much? You know that 1 by t equal to f. So you know that t is equal to 1 by f. They given you 25 kilohertz. They're asking you what is t. This you should give an answer so quick. You know how much time you should take. 1 second. If I say that, if I ask you F is equal to 250 hertz, what is T? 1 second. Can you give me in 1 second what is the duration? You know the problem now. Where is your problem? This is a problem which I'm telling you repeatedly. You don't practice small things. You do big things. In college. But yeah, perfectly correct answer. Somebody has given me 4 milliseconds. Yeah, so perfect. Now, I'm telling you F is equal to 25 megahertz. T equal to how much? 25 megahertz. T is equal to how much? I'm giving numbers are very easy only. I'm not giving a tough numbers. I'm giving easy numbers. You can divide them very easily. What is T? Others also can answer, please. I told you I need an answer in 1 second, but we have got enough of time. I'm trying to understand where we are confusing. I'm trying to help you out. I'm trying to help you out. No, it's wrong. It's not 4,000 milliseconds. I'm talking about 25 megahertz. So let me put you like this. Simple. You need to understand what it is. Yeah, let me tell you one thing. K is 1000. 10 power 3. K is 1000. 10 power 3. Okay. I'll explain to you now. Mega is 1 million. This is kilo. This is mega. Equal to 10 power 6. Then giga is G. 1 followed by 9 zeros. 10 power 9. Then tera. You heard about your hard disk is 1 terabytes. What is 1 tera? 1 tera is T. 1 followed by 12 zeros. Is equal to 10 power 12. Am I right? So now this is what we are using nowadays. Kilo, mega, giga, tera. Am I right? Here's a trick. This is 10 power 3. This is 10 power 6. This is 10 power 9. This is 10 power 12. I will erase this temporarily. So, kilo is 10 power 3, 10 power 6, 10 power 9, 10 power 12. Done. Because embedded means all over, embedded means timing. You should be good at timing. Then you will understand everything. Now, the other one is opposite of this is milli. That is M. 1 by 1000 or 10 power minus 3. 10 power minus 3. Then mega, the opposite is micro. Micro, 1 by 6 zeros. 1 or 10 power minus 6. Then what is this? This one, nano. Giga, it's called nano. N. 1 followed by 9 zeros. 1 by. It's equal to 10 power minus 9. And what is this? Tera. It is called pico. P. 1 followed by 1 12 zeros. 10 power minus 12. You understand now? This is what you will be using this 4 plus 4, 8. Kilo, mega, giga, tera, milli, micro, nano, and pico. Now you can erase all these things. You can erase all these things. Let me tell you symbols. K, 10 power 3. Mega, 10 power 6. Giga, 10 power 9. Tera, 10 power 12. Milli, 10 power minus 3. Micro, 10 power minus 6. Nano, 10 power minus 9. Pico, 10 power minus 12. Done now. Now you have to remember this. This has to be remembered by you. If you want, I'll write it here in the top. So because we'll be using in the calculation, you don't do that. I write here. Kilo means 10 power 3. Mega means 10 power 6. Giga means 10 power 9. Tera means 10 power 12. Okay. Let us remember this. 10 power 12. Now, the other one is milli, means 10 power minus 3. Micro means 10 power minus 6. Okay. Then nano means 10 power minus 9. Pico means 10 power minus 12. That's it. Very simple math. Now, if I say, understand one thing. T is equal to 1 by F. That is that the frequency is a cycles per second. Cycles per second, 1 second. This is one cycle, or we call one period, or one cycle. If I say 1000 cycles per second, this is called frequency. You would have seen in the college sine waves. They have a T. Same thing. Here is a square, there is a sine. No different. All your calculus, everything is based on that. This, your Fourier transform, everything is based on this. Now, T is equal to 1 by F. If I say frequency is 100 cycles per second, that means that like this one cycle, like this 100 per second, then what is the duration? 1 by 100 is the duration of this guy. 1 by 100. That's why they always say that T, time, this is what T. This is called T. Equal to 1 by F. You will understand why I'm explaining. This is all very important for the motor. This is all very important for the motor, how it is. Now, if it is 1000 cycles per 100 cycles per second, instead of using cycles per second, they use the word called hertz to honor the scientist Hertz. He is the one who invented the electromagnetic wave. So we call it as a 100 hertz. Now I am telling you that we'll take only one cycle. Let us take only one cycle. This is what going to repeat. This is going to repeat. This is called T, which we know. If I say F is equal to 25 kilohertz, what you should do is very, very simple. 25 into 10 power 3. I mean, because kilo means 10 power 3. It's a very easy for you. Do the sum. Okay. But, sorry, let me move this image, video left side. Now T is equal to 1 by F. 1 by 25 into 10 power 3. But if you say 1 by 25, then it becomes fraction. Normally we don't like fraction. So what we do here is, now you do the same thing. 1 by 25 into 10 power minus 3, because this, let's be here itself, sorry. Let us be here itself. Now we multiply this, the top and bottom, by 1000. Same, means 1. Multiply top and bottom by 1000. 1000 means, in this case, I can change it as a 10 power 3. So 10 power 3 into 10 power 3 is 10 power 6, equal to 1000 by 25 into 10 power minus 6. And 10 power 25 is 40. 10 power minus 6 is micro. So 40 microsecond. I'll give you a few more some. I'll give you few more, then you will understand. I'll give you a few more problem. Then you will understand this. This is called T, total time. If I say that F is equal to 20 megahertz, see that I say 200 megahertz, not 22, 200 megahertz. That means T is equal to 1 by, I write it here so easy to that. F is equal to 200 megahertz. Then T is equal to 1 by 200 megahertz, equal to 1 by 200 into 10, 200 into 10 power 6, because mega means 6. 10 power 6. But I told you that 200 is bottom. So multiply top and bottom by 1000. 10 power 3 is 1000. So this is equal to 1 by 1000 by 200 to 10 power minus 9, because 6 plus 3 is 9. It go to minus 9, equal to 5. 10 power 9 is how much? Nanosecond. 1 by hertz is equal to second, because T is always in second. So 5 nanosecond. So if I say F is equal to 200 megahertz, T is equal to 5 nanoseconds. That is what this time. Let us make one more example. That's the last. Then you should give an answer faster. If I say F is equal to 40 kilohertz, I say F is equal to 40 kilohertz. Then it's very easy. T is equal to 1 by 40 into 10 power 3, because kilo means 10 power 3, equal to 1 by 40 into 10 power 3 into 1000 by 1000. But here we write 10 power 3 because we can add it. Is equal to 1000 by 40 into 10 power 6, because 10 power 3 plus 10 power 3, 10 power 6 multiply, equal to 40 by 30 is 25. 25, 10 power 6 is what? Micro. So microsecond. Or you can write like this, still not confusing. 25 into 10 power minus 6. 10 power minus 6 is micro, equal to 25 microseconds. Understand? Let me leave this page as such. So try to do these sums in another 5-10 minutes. I'll come back after the break. I will leave this as such.